Welcome to my YouTube channel. This is Collins Odinga, a trainer in electrical and electronics engineering. So in my last post, we talked about Kirchoff's laws, where we discussed concerning both Kirchoff's current law and Kirchoff's voltage law. But now, in its application to the real to a real circuit now, it requires a little bit of insight, which is what I want to provide you today. So if you look at this example that I'm having here, we are having a circuit having two sources and their respective resistances across the circuit. So we are having E1, we are having E2, we are having R1, R2, and R3. So the question here is requiring us to find the currents at each and every resistance. So now, when you consider E1, E1 will be able to provide us with a current I1. E2 will also be able to provide us with a current I2. So, for you to calculate examples or problems in Kirchoff's laws, you have to consider the voltage drops and the voltage gains in the circuits. So how will you know that there is a voltage gain in a circuit? So we normally have two parameters. We have a source and we are having resistance and current flowing through the resistance. So for the gain, it means it is a plus. So for you to have a gain in a current source, it means current is flowing from positive to negative. So when current is flowing from positive to negative, that one is a gain. But then, when you want to know there is a gain in a resistance, you will see, you look at the direction of the loop and the direction of the current. You will realize that when the direction of the loop is in the opposite direction to that of the current, then you will be able to find what is called a gain. And how will you know we are having a drop? So for the drop, it will be the opposite at the voltage source. So that means the current there will be flowing from the negative to positive. So when current is flowing from negative to positive, that one is a drop. And when I say a drop, I mean use a minus. Then how will you know there is a drop in a resistance? You will know there is a drop in a resistance when the direction of the current is in the same direction as that of the loop. So when you're having a resistance there, the current is moving in that direction and the loop is also moving in that direction. Therefore, this one will be having or giving us what is called a drop. Having known that, so you come back to our circuit that we are having here. You need to identify the loop. So a loop means you need to know when you begin at this particular point from E1, this is a positive side, you need to move across the circuit back to where you started from. That one will be a complete loop. So our first loop will be here, but then we need to identify the direction of the loop. So allow me to use the direction of the loop to be in the same direction as that of the current. Therefore, let my loop also move in a clockwise direction. Then this is loop 1. Then again, this would be my loop 2. This loop 2, we are having current moving in an anti-clockwise direction. I'll use also the direction of my loop to move in the same direction. So this is loop 2. So I want us to look at this loop independently to help us coming up with two equations, and these two equations will help us solve the values of both I1 and I2. So let me begin with loop 1. So for loop 1, I want us to start from E1. You need to know, is E1 a drop or a gain? By considering this or by considering this other one, the direction of current. So the direction of current is from positive to negative. Therefore, that one is a gain because it is normal for current to move from positive terminal to the negative terminal of a given source. So therefore, we are having E1 as a positive. Then we will experience a drop here because the current is moving in the same direction as that of the loop. So we are going to have minus I1 R1. Then again, this current is moving at this particular point. So after reaching at that particular junction, you need to know which current is flowing through R3. So there now we have to consider what is called the Kirchoff's current law. And Kirchoff's current law is telling us the incoming current should be equal to the outgoing current. So we're having two incoming currents here. We're having I1 coming towards that node, having I2 coming towards this node. So it means the outgoing current there will be I1 plus I2. So I1 plus I2 will be the current flowing through the R3 resistance. So therefore, we'll also have, back to our equation now, we'll have minus R3 into I1 plus I2, then back to the source. And this equation should give us 0. So what normally happens, we open the bracket. First of all, we have to replace the values here. So E1 is 4 minus I1 R1. R1 is 2, so it will be 2I1 minus R3 is also 4. So that is 4 into I1 plus I2 should give you 0. So when you open the bracket, you have 4 minus 2I1 minus 4I1, then minus 4I2 is equals to 0. You collect the like term, let the constant cross the equal sign, you will have negative 6I1 minus 4I2 is equals to negative 4. When we drop the negative signs, we'll have 6I1 plus 4I2 is equals to 4. And this one gives us our equation 1. So loop 1 has already helped us to get the equation 1. So let's move to loop 2. Allow me to begin loop 2 from the source, E2. This one will be again because the current is moving from positive to negative. So therefore we are having a positive there, E2. We'll experience a drop there because the current is in the same direction as that of the loop. So that will be minus R2 I2. Then it will flow through this. So that will also be a drop minus R3 into I1 plus I2. And this one also should give you 0 because it will be back to the source. So replacing the values there, we are going to have 2 minus R2 is 1. So 1 times I2 will give us I2 minus R3, which is 4, into I1 plus I2. This one should give you 0. So this is 2 minus I2 minus 4I1 minus 4I2. This one giving us 0. Let the constant cross. So you'll have minus 4I1 minus 5I2 is equals to negative 2. Dropping the negative signs, we'll have 4I1 plus 5I2 is equals to 2. So this one is our equation 2. So we are having two equations. We are having two equations here. The first equation from loop 1, the second equation from loop 2. So we are going to use these two equations and solve the values of I1 and I2 using simultaneous equations. So the loop 1 was 6I1 plus 4I2 is equals to 4. And equation 2 is 4I1 plus 5I2 is equals to 2. So allow me to use elimination method to evaluate this. So here I'm going to multiply by 4. This one I'm going to multiply by 6. So opening that, you're going to have 24 I1 plus 16 I2 to be equals to 16. This one will be 24 I1 plus 30 I2. This one will give us 12. We're opening the bracket. Then what do? You find the difference. So this one minus this one will be 0. 16 minus 30 will give us negative 14 I2. And this one is equals to 16 minus 12 is 4. So therefore, I2 will be negative 2/7 amperes when you do the calculation there, right? So after getting I2, you can either use equation 1 or equation 2 to replace the value of I2, and that one will help you find the value of I1. So allow me to use equation 1, which was 6I1 plus 4I2 is equals to 4. Replacing the value of this, you'll have 6I1 plus 4 times negative 2/7. This one should give you 4. So in that particular case, you'll have 6I1 plus, that one will be negative 8, because it will be 4, yes, negative 8 over 7 should give you 4. Then this one should cross, it will be a positive, so you have 6i1 is equals to 4 plus 8 over 7. So when you do the calculation there, right, you will find the value of I1 to be 0.8575 amperes. So in this case, we are having both the values of I1 and I2. And the question was asking us to find the currents that are flowing in each and every resistances. So I1 is flowing through R1. So you simply use that value the way it is. I2 is flowing across R2. But then the negative sign in I2 is telling us that the direction of current should be in the opposite direction, but the magnitude remains the same. So for you to get the value of R3, it will be I1, which is 0.875 minus 2 over 7. And by getting that one now, you will be able to find the current which is flowing across R3. So thank you for that presentation. Welcome to my YouTube channel in my next post. Keep posted.